In this video, we'll be talking about problem 17 and 18. So these two are actually comparatively easier, and for the finale, it'll be very long. So this one is a penultimate video. So let's look at problem 17. Given a square ABCD, so I'll draw a smaller one because there's more space down there, so I'll be drawing down there actually. So point K divides the side AB in the ratio AK to KB equals to 2 to 1. So somewhere here and then 2 to 1. And then point L divides the diagonal AC in the ratio AL to LC is equal to 5 to 1. So find angle KLD in degrees. Okay, I'll move this down and then I'll draw it all over again. So we have this square, which is from my hideous drawing, so ABCD, and then we have our point K somewhere over here, which is 2 to 1. And then we have our point L over here, which has 5 ratio to 5 over 1. So because I'll be using a little bit of Pythagorean theorem inside here, so to simplify my steps, I'll be assuming AB equals to 6, has a length of 6. Okay, so now I can have this one. So this one I'll have a length of 4, and then this one I'll have a length of 2. And then KL, when you see, okay, I think we need to draw this one vertically downwards. Why can't I draw my lines perfectly? Okay, so we draw perfectly, not perfectly, but just vertically downwards. And then now what we see is, actually if we draw this out perpendicular to KB, oh my god, my lines. So if we draw this out perpendicular to KB, very hideous drawing. Okay, and then we will observe that maybe say this point is called O. Okay, so we'll observe that KO is actually equal to OB. So what this means is that if I link L with B, so this one, okay, I will yield LK equals to LB. Okay, noted? And then I actually, besides that, because this is a square, ABCD is a square, so what I can do is I can actually reflect LK and LB over the diagonal AC, and then if I reflect LB over AC, I will get my LD. So then maybe say I draw a point E over here, which also divides into lengths 4 and 2. Okay, and now I can say this one is a, okay, now I want to draw this downwards, so maybe I can write maybe a point F over here. So now we know that, okay, if I draw downwards, this means that my triangles LFC, so sorry for the bad notation, triangles LFC and triangles ADC are similar. And then we know that the ratio of LC to AC is equal to the ratio of FC to DC. So this one is 1 over 1 plus 5 equals to 1 over 6. So since we know the whole of CD is 6 because we add 4 plus 2, because I'm assuming this one already. So FC will have a length of 1, so which means this remaining FD is 5, and then because these two are of the same length, so this one also be 1, and then this one is a perpendicular one. So using the Pythagorean theorem, the length of DL is actually equal to DE is equal to LK equal to LB. It would be equal to Pythagoras will be equal to 5 squared plus 1 squared, and then the square root will be square root 26. Okay, and then now I don't know how you guys have done it. If you are interested in sharing your solution with me, maybe write it down in the comments below. But for me, this is, I could say, my crux move. So what I did was I add a line linking K and D. Okay, linking K and D, and then this one this one we know is 90 degrees because it's a square, so I know that 4 squared, so the length of KD would be 4 squared plus 6 squared, and then square rooted would be square root 52. So KD squared equals to 52. And then observe that the relation between 52 and 26 is 26 times 2 is 52. So maybe we can say, okay, LD squared plus LK squared equals to 26 plus 26 equals to 52 equals to DK squared. So if we know there is a Pythagorean theorem which states ABC, then this is a 90-degree angle, we know that this one can be, if there's a 90-degree angle, then we will have a squared plus b squared equals to c squared, c being the longer side, the hypotenuse. We also have a thing called the Converse Pythagorean theorem to be more exact. So I'm not writing the whole name. So in this, it states that, I see if I have more space down here, actually no. So let me erase some things, but I'll write this once verbally. I'll say it once verbally and then I'll repeat it later, okay? So the Converse Pythagorean theorem states that if there are two lines in a triangle, if there are two sides of a triangle, which both of the squares of which add up to the third side, then one of the angles inside this triangle will be 90 degrees. So maybe if say I don't know, I know ABC is here, but I don't know the angles of this triangle. So if a squared plus b squared equals to c squared, if this holds true, then it is true also that the angle between A and B is 90 degrees. Okay, so this one will be 90 degrees. So here our angle KLD, because this is root 26 squared plus root 26 squared is actually root 52 squared. So our angle KLD would be 90 degrees. Very magical. So yeah, so let's jot down our answers over here. And then for problem 18, if we add 2500 to a prime P, we get a perfect square. What is P? Okay. Note that for prime numbers are only divisible by 1 and itself. So some examples of prime numbers will be 2, 3, 5, 7, 11, and so on. And then also note that 2500 is actually 50 squared. So now we have and then a side fact, this P can be divided into 1 times P only lah, okay? So 50 squared plus P equals to some K squared, okay? So some K squared. So we can actually move this 50 squared to the other side, which is our 2500 lah, okay? We can move this 50 squared to the other side, then we will get P equals to K squared minus 50 squared, and then this one we can actually factor it down to K minus 50 and K plus 50, okay? So since this one is divided as follows, so now because we know this one is a prime number, so K minus 50 is definitely 1. So our K is definitely 51, and then our P would be K plus 50 is 51 plus 50 would be 101. So this one is actually you need to know the a squared minus b squared formula lah, okay? You need to manipulate it wisely. And yeah, this is the video of today, and tomorrow see you guys for the finale, I suppose. So ciao ciao.